Bismillahirrahmanirrahim. Welcome to the second part of the topic of linear programming. In the last part, we defined the linear programming and we said it is just a technique to solve an optimization or linear optimization problem, where the objective function is linear function and the constraints are linear inequalities. In this part, we are going to solve another example of the optimization problem. The problem says that we need to maximize the function f equal to 20x1 plus 30x2. So this is my objective function. Subject to for x1 plus 3x2 greater than or equal to 12, x1 minus x2 greater than or equal to minus 3, 2x1 minus 3x2 less than or equal to 0, and x2 will be less than or equal to 6. These are the constraints for the problem, and this will decide the feasible region. We said that the feasible region is just the region bounded by the constraints. We have 4 constraints for linear inequalities. These will create a region or bounded region between them. That region, we call it the feasible region. And we said the solution for the optimization problem, either maximizing or minimizing, must be in this region, in the feasible region. And since we are speaking about the linear programming, the maximum value or the minimum value will be at one of the corners of the feasible region. So to find the solution, let's graph the inequalities. I have 4 inequalities, and I want to find for the graph the line for each one of them. Say for first one. First one, I have 4x1 plus 3x2. We make it 12. So greater than or equal to 12. We are going to graph this line, and then we will decide which part is it above this line or under this line. Now to graph this line, we need 2 points. This is x1, x2. Either I will choose x1 equal to 0. If x1 equal to 0, then x2 will be 4. Or if x2 equal to 0, then x1 will be 3. So I have 2 points, 0, 4, and 3, and 0. To graph this line, the first point is 0, 4. This is 0, 4, and 3 and 0. Somewhere, this is 3, and this is 4. Now connecting between these 2 points to give me the line. This color black for this line. This is the equation, or the line of the equation for x1 plus 3x2 equal to 12. Now the inequality said that we should have a greater than, or we must have a greater than or equal to 2. So I'm going to choose a point not on the line. For example, if I choose the point 0, 0, the point, this we call it test point. If we choose 0, 0, and substitute in the inequality, I will have 0 plus 0 equal to 0, which is not greater than 12. It means this point 0 and 0, it is not in the solution, or it is not in the area of the solution of the inequality. So the solution for the inequality will be the other side. So this is the solution for the first inequality. Now let's go for the second inequality. Second inequality say that we have x1 minus x2 greater than or equal to minus 3. This is the second one. Number 2. It is x1 minus x2 greater than or equal to minus 3. I'm going to say minus 3 or equal to minus 3 to graph the line. Again, I need 2 points. x1, x2, 0. If x1 equal to 0, then x2 will be 3. And if x2 equal to 0, then x1 will be minus 3. So the first point is 0, 3. And minus 3 and 0. Say this is minus 3. Now connecting between these points. This will be the line x1 minus x3 equal to minus 3. Now I need to test the point. We have greater than or equal to minus 3. The inequality is greater than. So if I choose 0 and 0 again, I will have 0 minus 0, which is equal to 0, but this is for sure greater than minus 3. So the 0 and 0 will be in the solution of the second inequality. It is down. This point is in the solution of the inequality. Now, third inequality or third constraint, I have 2x1 minus 3x2 less than or equal to 0. This is my third inequality, this one. I have to make it equal to 0 to graph the line. x1 and x2. If x1 equal to 0, then x2 will be 0. This line is passing through the 0 and 0. Now I will choose now another value for x1 because I got 0 and x2. Let's say that I'm going to choose 1 for x1. So 2 times x1 equal to 2. To move it to the other side will be minus 2 divided by minus 3. X will be 2 over 3. 2/3. So I have, let me choose this color now. I have 0, 0, and 1 and 2/3. It's somewhere up. We have now this is the line of the third inequality. Now I need to choose one point which is not 0, 0 this time. I can choose any point on the x or the y axis. I can say 0 and 1. I'm going to choose 0 and 1 to test. So in this case, if I choose x1 equal to 0, I will have 2 multiplied by 0 minus 3 multiplied by 1 equal to minus 3. Minus 3 is less than or equal to 0, which is okay. Go back to see. It is less than 0. We need to satisfy this condition. So 1 and 0 is in the area of the solution. So we can say it is up this time. The solution for the green line will be up. Last inequality, we have x2. This is number 4. We have x2 is less than or equal to 6. So I can say it is equal to 6. So we will have, this is 4, this is 6. There. Let me choose this color this time. This is horizontal line. And It is less than 6 means it is down. Okay, we will have this. Now we can see the feasible region if we just clear this outside the bounded region. The common area, this one. Go to clear this just to make it. So the bounded area will be, or the common area. You can see it is this one. So it should be, well, the blue is down to be this area. So this is the bounded by the 4 concentrates. So we call this is the feasible region. So this will be my feasible region. And for this region, we have 4 vertices, 1, 2, 3, 4 corners. V1, V2, V3, and V4. I have 4 corners. So I need to find these corners and evaluate the function at each one of them and take the maximum value. So let's find V1. So V1, it is the, okay, to find V1. It is the line x2 equal to 6, the intersection between x2 equal to 6 and the line, the green one, that one is equal to 0, that will be 3 or 2x1 minus 3, x2 equal to 0. This will give me, if x2 equal to 0, I will have, I'm sorry, x2 equal to 2. This will be minus 18, 18, this will be 9. So it is 9 and 6. These are the coordinates for V1, 9 and 6. For V2, we go for to find the V2. V2, this is V2, it is equal 6, and the blue one, that is 1 second, that we need to find. Okay, this one. x1 minus x2 equal to minus 3. So it is x2 again equal to 6 and x1 minus x2 equal to minus 3. This time will give me, will be 6 minus 6 to move to the other side will be 3 and 6. These are the coordinates for the second one. For V3, what you see, this will be V3, it will be the black one and the blue one. This 2x1 minus 3x2 equal to minus 3 and it will be 4x1 plus 3x2 equal to 12 and x1 minus x2 equal to minus 3. This is the system of linear equation, and we need to find x1 and x2. If I can multiply the second one by minus 4, this is minus 4, this will be plus 4 and plus 12, and add them together. So cancel, I have a 3 plus 4 is 7. x2 equal to 24. So x2 will be 24 over 7. Use this one to find x2. So x1. x1 equal to minus 3 plus x2. I can say minus 3 plus 24 over 7. That will give me 3 over 7. So it is 3, it is 7. And 24 over 7. So this is V3. Now we need to find the last one, which is V4. This one. V4 is the system of the two equations for x1 plus 3x2 equal to 12 and 2x1 minus 3x2 equal to 0. If you add them together, I will have 6. x1 equal to 12. This will give me x1 equal to 2. And x2 will be, in this case, move it to the other side, will be 4 minus, it is 4 over 3. So the coordinate for V4 will be 2 and 4 over 3. Now all what we need now, we need to find the value of the function at each one of these. We have vertex I, and we have the function f, which is given by 20 x1 plus x2. So the first vertex, we say this is equal to 9, 6. This is 9, 6, 3, 6. V3, it was 3 over 7, 24 over 7. And last one was 2 and 4 over 3. Evaluate at the first one at 9 and 6. Replace x1 by 9. I will have, in this case, this will be 180 plus 6 times 30 is again 180. 360. At the 3, 6, I will have 60 plus 6 times is 180, which is 240. Third one, 20 times, this will be 26, or I'm sorry, 60 divided by 7 plus 720 divided by 7. That will be 780 divided by 7. It will be about 110 or 112. It is 112. Third one or the fourth one, 20 times 2, this is 2. We'll have 40 plus again 40. That will be 80. And now we can see that the maximum value is the 360. So we can say the solution will be maximum value is equal to 360. And this one x1 equal to the first vertex 9 and x2 equal to 6. So this is the solution for this optimization problem. So the best solution or the maximum value is equal to 360 and x1, this is when x1 equal to 9 and x2 equal to 6. So this is the idea of solving linear programming problem or linear optimization problem. We need to graph the constraints, decide the feasible region, and then check for the corners one by one. Take the corner point and evaluate the function at each one of the corners. Take the maximum value if the problem is maximized, and take the minimum value if the problem is minimized. And that will be the maximum or the minimum value for the problem at the given location. X1 equal to 9 in this problem and x2 equal to 6.